Wow, this is a video about a radio receiver of an unusual kind, and something I've been looking at about as long that I've possessed this as long as I have my TCS-13, which I picked up in high school in 1982 in April in the surplus room, because Stan WD60QV says we have to clear it out. So he gave me the gift of the TCS and other things. And a student, or Stan himself, had made this receiver. It's based on two ECG 102 alpha germanium transistors. And where have I seen those before? I've seen germanium transistors with their high. So I did the schematic after I got this baby to work again. Of course, I made a visual schematic in my mind, and I had to make a wiring change, which was wrong, and make the negative rail black wiring because the student had done red wiring and everything, and that's kind of dumb, or needed to learn. So if I got the wiring. So anyway, but over the more or less, it's the same thing. And then I got a spider web coil. And courtesy EPD Labs in Nevada, I was given these 3 transducers, high impedance transducers. Interesting. Test transducers, headpieces for calibration of equipment. So I have the plus 4.5 dB one in here. But it makes a nice. Lawrence Rowland, a friend I met a decade ago, a musician in Marin County. I met him camping out here in this area, and he gifted me his CD while I gifted him Aurora Chorus too. So the soundtrack isn't copyrighted. Shouldn't be any issues with YouTube, etc. Tribute to Lawrence Rowland here. But I did this schematic, and this was given to me by Stan, and it was interesting how we'll stick it this way, get a good view of these. Germanium transistors are interesting creatures, unlike silicon NPN, which I work with a lot, and the TA7642, this chip here. This IC is what I do, the restoration of the antique AM receivers. Now this one has its all, this is another restoration here, but this has its original complement of that, virtually everything, including capacitors and vacuum tubes, and it works like brand new. But that's another story. That's another video story. But I learned about germanium transistors a long time ago in the 70s from this. And this has these 2SB56 PNP transistors, and I made their little kits. And of course, this is a second version of the Radio Shack Science Fair 65-1. I got the original in the early 70s. This is a replacement I picked up 10 years ago on eBay. And of course, I did make some improvements, N6NKS improvements to the transmitter. And in a following video, we'll get this to broadcast to the one germanium transistor audio amp here, powering audio amplifying, AMing the NPN transistor 2SC based oscillator in the little kit here. But so this was how I progressed in my electronic knowledge from the beginning of the 70s as a 8- and 9-year-old. So anyway, I've been looking at this board for a long time. It's just been kind of a decoration on the shelf above the TCS, sort of, in the other section of the shop building here. And I said, it finally occurred to me 2 days ago, I said, let's get that to work. It just needs a tank circuit, which was missing. And I believe it's a 2-stage audio amplifier, which it is, based on these germaniums, which are self-biasing, so they don't need any base forward bias from the collector as the NPNs do if you've got a common emitter. These are common collector being PNPs, common collector, and they really don't need, they're self-biasing like a JFET as far as needing that other resistor to tickle the base to bring it into class A mode or AB mode or whatever for linear, as linear amplification as possible. So we have these two audio amplifiers here, first stage and second stage, fairly identical. I added the 100K base resistor, which was missing. No student put that in there. It actually increased the volume a little bit of the stage 2. And I added the asterisk components are ones that I've added that were missing, and there was a wiring error, like going to the collector instead of the base, which I figured out and fixed. So in the end, and of course I do have it earthed to the super ground of the whole station here, N6NKS station, but also to my, oh yes, this is the other joy. This is a whole other super sensitive joy of the homemade dual band TRF TA7642 again, playing the we'll show the modulating transmitter at the toward the tail end of this. Probably is going to be the longest video. Yeah, but this beauty here, and I will switch hands so I can tune the tank circuit on the spider web, which I got off of an eBay seller who's into crystal radio construction and refurbishment. So this is basically a crystal radio. There's your 1N34 alpha diode, cathode toward the tank circuit, and goes to the NPN first stage, which is basically this. Nice, beautiful, elementary, beautiful, simple. Look at the common emitter and then a positive. There's not even a bypass or electrolytic padding capacitor on the circuit. And you can either use the plus or the ground as the second audio output for the headphone. It doesn't care. It works equally as loud on the ground as one of the leads as on the positive rail, the emitter. Of course, there's the isolation capacitor there. So it works beautifully, but I just have it going to the positive like this, but it doesn't, you know, it could be on the negative side. And the volume's the same. It's not getting any voltage because of the isolation capacitor, 25 microfarad. That guy is this one. So this is the circuit, and it's beautiful. And I'm going to hook it up to an antenna, one of these videos, with a big antenna that won't hopefully degrade the Q of the tuning section too badly, but if it does, it'll be an interesting mixture. And see what we can DX this, because I don't really have an external antenna on it, just the loop it's picking up, and but it ought a large antenna should be transformer coupled to the main tank circuit through a second winding, maybe a single turn near it or something, not directly connected. That'll dampen down the tank circuit Q too much, make it too broad. So we want to do some kind of coupling of a big antenna to this, but it will really probably DX pretty well. That'll be in another vid. But this is this, and I just think it's such a cool thing. Finally, I worked on the last couple of days to get to working. So we're going to do some really cool zoom-ins of this unit here, which you see the fan stock clip construction of it all, and these germanium transistors. Look at the architecture of this. Now, how many digi-heads with their bazillions of Moore's Law transistors ever trying to squeeze them down into the digital beast, see the beauty of the analog world where you only need 2 transistors to pick up music, and it sounds good. Although it's digitally being played on a Kobe player to the transmitter on FM 1015 and AM 1440. This is transmitting the low power 100 milliwatt AM transmitter. Is signal generator cube in the other room is 1440-ish. So this is my daytime Keeley Community Radio frequency, because it doesn't have a birdie on the portable radio like 1500 did, and it's a good, very minimal ground wave signals from elsewhere. But all you need is 2 transistors, and you hook it to an antenna and a detector diode, and you get, it's beautiful, it's elementary. Dear Watson, it's just elementary, and that's what's so beautiful. Things can get very complicated in the technological world, and it can be such a daunting turnoff to the newcomers in electronics. I encourage all the younger folks, as I did when I was 8 or 9 years old, to get into this. It's going to go back. There will always be a need for analog engineers. The square wave digital switching heads and all that world is amazing and fascinating and quite daunting too. But there's something elementary about the transistor, especially the germanium. And they sell these things. There's still like a whole surplus market of Sylvania transistors. These came with the thing. So these are the originals. I didn't buy these to replace, but they are available. So here's the schematic. That's all it takes to pick up your local AM broadcast station and or self-generated signal, as I'm doing. And what do you get? It only takes 2 transistors and a nice headpiece. And look at the architecture. Here's the heart of the receiver. You can't do this with Wi-Fi. So here's the schematic one more time. At whatever angle you prefer. Portrait or landscape. That's the schematic. Simple, elementary, dear Watson. Down to even the origins of the transducer. So, that's your antidote to excessive high technology is elementary technology. This is the mystical magic of it all, too. Inductance. Inductance is the core of it, of all the electromagnetic physics to study. What is most ephemeral is inductance. N6NKS said that. All right, folks. I'm going to sign clear.